Hi, my name is Tu, and so I have been working on a project for TDW. It is their power monitoring system for their lithium polymer batteries, and this is for the co-op credit for the ECE program. So I set up this microcontroller connected to the Arduino Ethernet shield. I have some input and outputs to a breadboard, and the microcontroller is connected to the LTC wide range monitor via I2C. The jumper cables on the right connects to the load, and the jumper cables on the left connects to the battery. So in this video, I'm connecting it to a power supply instead of a battery. I'm using an electronic load to dissipate the battery at a constant resistance, and the monitor will take the current and voltage measurements. Here, I'm using the power supply as my battery at 15 volts, and I'm gonna go ahead and restart my program and see that the LED blinks green to let me know that the SD card is ready to be written. So there it goes. The system sits in idle mode until I press the button to start the data acquisition, and here it goes. Lets me know, and so the LED stays red to let me know that they're gathering data and to not power down the system. My system will record the voltage and current you see here, and next I'm going to turn the voltage to a value to set off the under voltage lockout unit. So I'm going to set it to 2 volts. You can see here that the voltage changed, and the LED stays red for another 5 minutes to gather an additional data until the battery is soon dissipated. And so this test is meant to test the integrity of our lithium polymer batteries, because we've been having problems of over dissipation on these batteries. And so the electronics team came up with the under voltage lockout unit circuit to be placed in these batteries in case it over dissipates. So we have it set that it should trigger a lockout unit at a certain voltage. And so what this does is it tests the integrity of that lockout voltage to see if it's actually there or working. And I found out that there have been batteries that don't have a lockout unit that's been placed inside, and so we have to go back and talk to the manufacturers and let them know that their batteries don't have them, and that we should do something to put them in, because it's a hazard to have these batteries over dissipate and also overcharge as well. But for this test, I only test the over dissipation. So during this whole time, it's gathering the data and actually writing to the SD card you see in the SD slot. And it's gonna go for another 5 minutes, but I'm not gonna go towards the end and let you see when it ends, the LED should blink green to let me know that it's okay to remove the SD card. If you remove it before, you get some corrupted data and it won't write to it all the way, and so it needs to be flashed before you can remove it. And so that's why I have it wait for 5 minutes when the battery ends. But yeah, that is my project, and currently this project is being handed off to more senior engineers to incorporate this company-wide, so the technicians may be able to use it. They'll make this design very modular and teach the technicians on what to do. I'll include the data, the Excel file that the data writes to. It'll show you the power, the current, the voltage, and then it'll show you a graph of the behavior of the voltage and current, and I'll also show you some other measurements, but we're mainly more concerned about current and voltage. I guess I can see if I can also add my program in that I made for this. It's a long, but yeah. All right, and that is it. I don't think you want to see this anymore, so I'll just end it here.